Now, the sea stands ready to provide the most valuable commodity of all, perpetual renewable energy, energy from the ocean. Technology has made possible the extraction from the sea of the limitless energy it can provide. We can use ocean power as renewable sources of energy, but we must act, and we must act now. Ocean energy resources fall into 5 main categories: tides, currents, waves, salinity gradient, and temperature gradient. A good example of tidal technology in action can be seen in the highly successful barrage across the Rance River in the north of France. Over 40 years old now, this installation generates much of the energy for the local area. The theory is simple. Potential energy linked to the fall of tides can be harnessed by building fixed or floating barrages. The tide flows in and drives huge turbines, which in turn generate electricity. Tidal current power is about placing modular underwater turbines directly in stream to generate power from the flow of water. Wave energy is renewable. There are a wide variety of devices or systems, each using the movement of waves to harness the power of the sea. This wave energy plant can be shore-based, floating, or underwater. But it is not only motion that can provide useful energy. A system to generate power from the sea is by using the difference in salt content between river water and the sea. It is a tried and tested technology which has been rolled out in industrial scale. Most innovative use of the sea to generate power can be seen through the process of OTEC, Ocean Thermal Energy Conversion. The surface of the sea is always warmer than the water at depth. Warm surface water is pumped through a heat exchanger, where a low boiling point fluid such as ammonia is vaporized. The expanding vapor turns a turbogenerator. The cold, deep seawater is then pumped through a second heat exchanger, which condenses the vapor back into a liquid to recycle through the system again. The IPCC is the most authoritative scientific body on climatic change. It is concluded that global ocean energy does not generate greenhouse gases in operation and has low life cycle GHG emissions. Further, just one kind of ocean energy, wave energy, is equivalent to twice the global electricity supply. Ocean energy accounts for a small portion of current energy supply, but it has a great potential too. The greatest ocean power installation is in France. Canada's Fundy Bay tidal power plant is the third largest in the world, just behind France and South Korea. Why ocean energy in Canada? Because ocean energy is sustainable, eco-friendly, efficient, cheap, self-sufficient, and predictable. Ocean power is eco-friendly because it can reduce carbon emission. Energy BC's study shows a clear relation between ocean power and reducing carbon emissions. The IPCC study confirms that hydro and ocean powers have the lowest carbon intensity among all kinds of energy, lower than wind, biomass, and geothermal, not to mention natural gas. Further, ocean energy has low effects on the environment. Wave energy, stream energy, and OTEC do not require the building of a permanent dam to block the water flow. Current designs of turbines can allow fish to pass through. Therefore, ocean energy has minimum effects on the environment. Energy efficiency is the efficiency of power plants to convert the fuel into electricity. The higher the better. Hydro and tidal power have the highest electricity generation efficiencies among all energy sources. Energy efficiency of coal is 45%, gas 40%, nuclear 40%, wind 35 to 40%, biomass 40%, solar 20 to 30%, geothermal 15%, and tidal power has 90% efficiency. There is a belief that ocean power is expensive because the startup cost is high. Actually, based on the study of the IPCC, ocean power's all-in cost is comparable to other renewable energies. Importantly, the cost of ocean power can be and will be lowered drastically when the capacity factor is increased. Remember that the operating cost of ocean power is very low. Ocean power can be considered as a kind of cheap energy. Canada is self-sufficient in ocean energy. According to the study of Dr. Andrew Cornett of National Research Council Canada in 2006, Canada's total potential wave energy in Atlantic and Pacific waters averages 2.5 times Canada's total electricity consumption. Theoretically, ocean energy will not run out in Canada because first, ocean energy is nearly inexhaustible, and secondly, Canada is bordered on 3 oceans, Pacific, Arctic, and Atlantic, with over 200,000 kilometers of coastline, and possesses a lot of waterways, St. Lawrence and the Fraser River. Ocean energy potentials is abundant. The east coast of Canada has an estimated average wave power of 146.5 gigawatts. BC has a tidal potential of 4,000 milliwatts. Waves propagate over thousands of miles of ocean, and their size and energy content can be known from 3 to 5 days in advance. Tide is regular as depth and taps, and ocean water flows all day unlike solar and wind. Ocean power is smooth, persistent, and predictable.